All right, welcome to 11-7 Day 2 Notes. Today we're going to be talking about factoring polynomials of degree 2 that has 3 terms and has a leading coefficient of anything. So we've just talked about leading coefficient of 1 using the x method, and then yesterday we learned about leading coefficient prime, so there wasn't that much variability in the beginning. But today we're going to talk about a could be anything. The steps are still the same. We're still going to factor out a GCF. We're going to find our factor pairs for A and C, and we're going to guess and check. The only thing about this method is that there's more variability, so we'll have to check a few more possibilities. All right, so number 1 says 6x squared minus 11x minus 2. First step is to find a GCF. Again, I always take the smallest term and see if it goes into all the terms evenly. 2 does go into 6, but does not go into 11, therefore 2 is not a GCF. Then check the factors of that smallest number. Well, the factors of 2 are just 2 and 1, so there is no GCF numerically. Next, check your variables, x squared, x, nothing. So there is no GCF. So I can go ahead and jump straight to step 2, which is finding the factor pairs for A and C. So my A value is 6. So how do you get 6? Well, that's 1 times 6 and 2 times 3. Factor pairs for my last term, my C value. How do you get 2? Well, that's 1 times 2. All right, so we have to check all these combinations. You might just get lucky and be able to save time, but I do need to go ahead and check my combinations. I usually recommend starting with the closer together values. That's usually the answer, not always, of course, but most of the time it is. So I am going to go ahead and check 2x and 3x first. Once you've chosen 2x and 3x, I now have to check my pairs at the end. So I have a 1 and a 2. I could put a 1 here and a 2 here, or swap them and put a 1 here and a 2 here. So I'm just going to try a 1 and a 2. I'm going to check my inner product. 1 times 3x is 3x. And my outer product, 2x times 2 is 4x. Well, can 3x and 4x give me a negative 11? No. So I'm going to swap those answers and try a 2 and a 1. Well, 2 times 3x is 6x. And 2x times 1 is 2x. Can 6 and 2 give me negative 11? No, there's no way. So using 2 and 3, I have tried every possible combination, which means that 2 and 3 must be wrong. In this case, the closer together ones were incorrect, but usually you're going to find your answer within those. So my next combination, let me go ahead and erase this so I have some room. My next combination is to try the 1x and the 6x. So I'm going to go ahead and make room for that. So 1x and 6x. And again, what we're doing here is we're forcing this first term. 1x times 6x is 6x squared. We forced that term. Then we're trying to force this last term. So I'm going to try a 1 and a 2. So I'm just going to put a 1 here and a 2 here. Check your inner product. 1 times 6x is 6x. Check your outer product. 1x times 2 is 2x. Can 6x and 2x give me 11? Okay, so I have chosen every possible wrong answer. The last one hopefully works. So I'm going to put a 2 here and a 1 here. I just swapped the order. 2 times 6x is 12x, and 1x times 1 is 1x. How can I make a 12x and a 1x become a negative 11x? Well, I want to keep the sign of the bigger, so I'm going to make it a negative 12x and a positive 1x. 1 minus 12 is negative 11, or negative 12 plus 1 is negative 11. All right, and the way these signs work is my inner product, my sign goes with my inner product. So negative 2 times 6 is a negative 12. And my outer product, the sign comes here. All right, everything should be chosen correctly. You should have chosen values that force that A value. You should have chosen numbers that force that middle B value. But always double check at the very end your signs. Is negative 2 times positive 1 in fact negative 2? And that is correct. So this is my final answer. We did have to try 4 different combinations to get it right, but that's okay. Most of the time you will kind of guess correctly on the first or second try, but some of them do require several steps. But again, if you want to double check like in its entirety, you can always multiply all these terms out and double check. You get the same thing back. All right, so question 2 says 4x squared minus 4x minus 15. Again, step 1 is to factor out a GCF. So check my smallest term, 4. Does 4 go into 4 and 15? Well, yes and no. So 4 is not a GCF. The factors of 4 are 4 and 1 or 2 and 2. But 2 also does not go into 15. So there's no GCF numerically. x squared, x, no x. So same scenario, no GCF. So I'm going to go ahead and jump to step 2, factor pairs. The factors of 4 are 1 and 4 and 2 and 2. The factors of 15 are 1 and 15 and 3 and 5. So I do have several more options here. I'm just going to go ahead and pick, again, I recommend picking the closer together options just because it's more likely to be true, but again, not always. So I'm going to go ahead and just pick 2x and 2x. Again, I'm forcing 2x times 2x is 4x squared. I'm forcing that a value. Next, I'm going to go ahead and try my c values here. So I'm just going to pick 3 and 5. You could have chosen 1 and 15, but it doesn't matter. Also, it doesn't actually matter about 3 and 5 or 5 and 3 because these numbers are the same. So you actually kind of have a little easier problem here. But I'm going to check my inner product. Oops, I don't know why I wrote that. My inner product and my outer product. Okay, can I make 6x and 10x be a negative 4x? Well, yes, I want to keep the sign of the greater, so my bigger number needs to match that sign. So 6 minus 10 is negative 4. Again, inner product signs go on the inner product. Outer product sign goes on the outer product. Double check that you've done that correctly. 2x times 2x is 4x squared. These numbers in the middle should be fine because you just did the math. And double check your sign. Is positive 3 times negative 5 negative 15? Yes, I got this guy on the first try, so that's nice when that happens. Question number 3, 10x squared plus 19x plus 6. Check for GCF. I always pick the smallest number. Does 6 go into 10 or 19? No. The factors of 6 are 2 and 3, so check the bigger of the two. 3, well 3 doesn't go into either. 2 goes into 10 but not 19. So there's nothing that goes into all of them evenly, so no GCF numerically. X squared, x, no x, so again another one with no GCF. So I'm going to go ahead and list my factor pairs. So we have 10 is 1 times 10 or 2 times 5. 6 is 1 times 6 or 2 times 3. Again, it does not matter at all what you choose as your first pairs, but you might just get lucky and pick the right stuff off right off the bat. So I again like to pick the closer together ones just because it's more likely to be accurate, but again, not always. Alright, I've chosen 2 and 5, so I have the option of 1 and 6 or 2 and 3. I almost always just pick the closer together one, so I'm going to pick a 2 and a 3. Inner product, 2 times 5x is 10x. Outer product, 2 times 3, that's a 6x. Well, 10x and 6x can never give me 19x, so I've chosen the wrong order. So I'm going to swap these guys. So I'm going to put a 3 here and a 2 here instead. Okay, and then I'm going to check my inner product again. 3 times 5 is 15, and 2x times 2 is a 4x. Can I make 15 and 4 give me a 19? Yes, and I want a positive 19. So I need a positive 15 and a positive 4. Again, inner product sign goes here, outer product sign goes here. Really, the only thing you have to double check is this sign at the end. You should always check the entire problem. But double check, does positive 3 and positive 2 multiply to give you a positive 6? Yes, that is correct. And we got off easy on this one as well. If you had chosen 1 and 10 initially, you would have had to try 1 and 6, 6 and 1, 2 and 3, 3 and 2, and then move over here. So just hopefully you get lucky when you try the closer together numbers first. Question 4, 9x squared minus 24x plus 12. Step 1, try to find a GCF. So again, smallest number is 9. Does 9 go to 24 or 12? No. Factors of 9 are 3 and 3. So does 3 go into 24 and 12? Well, yes, it does. So this guy actually does have a GCF. So I'm going to go ahead and write parentheses with a 3 on the outside, and I'm going to divide each term again by my GCF. 9 divided by 3 is 3. I'm not taking any x's away, so I'm still going to have x squared. Negative 24 divided by 3 is a negative 8. Be careful that you actually look at your signs there. And positive 12 divided by 3 is a positive 4. All right, so once you've factored your GCF, you're going to do the same thing we have been doing your factor pairs, but you're going to ignore the 3 for now. So my factor pairs are for this 3 and for this 4. So my factor pairs are 1 times 3 1 times 4, or 2 times 2. When you're doing this, do not forget to bring down that 3 GCF. So I'm going to go ahead and plug in my values. I only have one option. I have to pick a 1x and a 3x. It's actually really nice when you're forced because there's no other options. Now I have the option of picking 2 and 2 or 1 and 4. So I'm just going to go ahead and pick 2 and 2 because they're the closer together. Check my inner product, 6x. Check my outer product, 2x. Cool. How do I make 6x and 2x give me a negative 8x? Well, I need a negative 6 and a negative 2. So inner product negative, outer product negative, and we also guessed correctly on the first try there. So my answer is this. Make sure you don't forget that 3x. Also, you don't need to write the 1. You could have written just x there as well, and that's totally fine. But that's your answer. All right, for question number 5, again, step 1 is to find our GCF. So looking at my numbers, my smallest number is 6. Does 6 go into 14 or 8? No. The factors of 6 are 2 and 3. 3 doesn't go into either of those, but 2 does. So 2 is going to be my GCF. Then check your variables. X cubed, x squared, x, they all have 1x. I'm going to go ahead and take an x out and do 1 long parentheses. Again, don't forget, if you have a trinomial, when you factor out your GCF, you'll also have a trinomial on the inside. You don't lose any terms. All right, I'm going to divide each term by my GCF, which is 2x, and just do the math. 8 divided by 2 is 4. This guy's top heavy. It's essentially 3 minus 1. I have x squared left over. Negative 14 divided by 2 is negative 7. X squared, take away 1x is 1x. Positive 6 divided by 2 is a positive 3. And x cancel. Again, we're going to ignore this GCF for just a minute and do our factor pairs of our A term and our C term. So factor pairs are 1 and 4 and 2 and 2 and 1 and 3. All right, again, don't forget your GCF, so that 2x comes straight down. And I don't actually have a lot of space, so I'm going to go ahead and do this guy in pencil for both of them. So I'm going to go ahead and I'm going to try 2x and 2x first in case I'm wrong. All right, so 2x and 2x, and again, get the same number. It's really nice that you don't have to swap those. So I'm just going to go ahead and try a 1 and a 3. Inner product, 2x. Outer product, I'm just going to write it over here, 6x. Well, can a 2x and a 6x give me a negative, oh, sorry. So we're actually done with this guy right here, so make sure you don't make the mistake I almost just did. Can 2x and 6x give me a negative 7x? Well, no, they cannot. So I don't actually need to swap them because I would have the same inner product and outer product. So that means that 2, 2 is wrong, which means it has to be 1, 4. So I'm going to go ahead and erase all of this. Okay, and my guy's there. And I'm going to cover this guy up here. I'm going to go ahead and try a 1x and a 4x. Okay, once I have the 1x and the 4x, I only have the option of 1 and 3 or 3 and 1, so I'm just going to try 1 and 3. Inner product 4x, outer product 3x. Can a 4 and a 3 give me negative 7? Yes, they can. If I have a negative 4 and a negative 3. Inner product, negative 4. Outer product, negative 3. And when I say negative 4, I mean negative 1 times 4. That's how I get my negative 4x there. So that actually is my final answer. Double check, though, always double check. Is negative 1 times negative 3 in fact a positive 3? And that is correct. But most of the time, if this is going to be prime, meaning it can't factor, it's going to be this sign issue. You're forcing the signs to make the B value work, but these signs for your C value will probably be where you end up with a prime answer.